This is part 3 in a series of videos in which I'm looking at this ASR33 teletype. And in the first videos in this series we stripped the unit down completely, cleaned up the printer, the chassis, refinished the chassis, replaced the foam, and took the motor out of the printer, which is this part of the machine, and I got as far as washing it, and it's now been drying for 24 hours and fully dry, but it's still very tight. So if you recall, this wouldn't rotate at all when we first started, but after cleaning and doing nothing else it will at least rotate, but it is very tight and almost nothing on it is working. Although it's rotating, none of the levers and ratchets and cams are working at all. We've got a broken part down here, we've got a badly damaged part on the timing mechanism. I did make a replacement platen knob for this, so we can at least now turn the platen. And the only other thing I've done is I spent some time with some 7000 grit abrasive paper, and I've cleaned up the commutator. I took the brush holder off and gave that a good clean, checked the brushes, they're fine, they're not very worn at all. You can probably see the end of one here, so it's quite long, there's no real serious wear on those. This is cleaned up very nicely. There was some pitting on there but not too deep. Now although you've seen me rotating the machine with this, I don't recommend doing that. This is very brittle, very easy to break. It's better to turn it using either the main gear or the other end of this main shaft, and that's what we'll be doing in this particular video. So what I want to do in this video to start with is see if we can at least get some of the parts freed up that are frozen. So there's lots of small items here, and although it's extremely tight, when I try and turn this, it seems to be just a combination of all the different shafts, and various parts are very tight. And what you can do is just work your way through, starting at the main gear, and if you rock it back and forth, there's some backlash in most of the gearing, so you can normally tell which ones are tight. So this one's not too bad. This bearing is fairly badly worn, there's some play in it. You can quite easily make a new phosphor bronze bush for this, and I'm not going to, it's not badly worn enough to replace, but at least it's not tight. It needs lubricating, but it's not too badly worn. The other end I suspect is very tight, so really it's a combination here of trying to find out which bits of this are tight. So for example, this bearing is very tight, and we can lubricate that and hopefully it will free up. This shaft has a tendency to get very tight. We've got a bearing at this end, and we've got another bearing down at this end, and again they get very tight. And I suspect this is one of the main culprits, because I can barely turn this. If you try and slide it back and forth, it will move, but you can feel how tight it is. Okay, so that will need lubricating. It's just really a case of lubrication. If we can't clean it up by lubricating, we will need to take this out, but I like to avoid that because it is a real pain getting that shaft out. And then the rest of the parts, you can just test each one individually and see if they will move. Now they're moving, they're quite tight, but they are returning under spring tension. But if they're even slightly tight, then all this will add up and give you a very heavy feel on the drives. That's not too bad. That's a bit tighter, but not too bad. There's one down here which is actually stuck, so that won't move at all. Let's bring a light in. So this shaft down here, or this lever rather, should move, and it's not doing. Okay, it's moving, but it's staying where I'm putting it, so it's obviously very tight. So we'll need to lubricate that. The basically there's a cam follower, there's a cam and a cam follower, and that should be moving fairly freely, and it's not. All these levers down here, these are the selector levers. These are what the solenoid operates on. and they're moving, but some are staying where I'm putting them. So again, that's just a case of lubricating this rear bar. Spin the unit round. And so on the front, it's very tight trying to move the carriage, and it's not returning. Something else that I've noticed that's odd is this is loose. So we'll need to make sure that is properly secured. It's supposed to be self-centering, but it's flopping about, so we'll need to move that. This should now have returned under spring tension, so obviously something not working the way it should. The ratchet feed for the tape wasn't working, but I've just operated that a few times and it's kind of starting to work, but it's tight, so it will need lubricating. So it works in both directions, but it's very tight. But that's just a bit of oil that's needed. I'll replace this rubber bumper. It's rock hard, not as bad as the last one we did, but certainly if we try to run it like this at speed, it would damage the print head. We've got a lever down here that's stuck. So if we move this lever across and open it up, you can see it doesn't really return properly. And that's part of the ratchet control. Same with the rest of it. The rest of it is moving, but it's very sluggish. So we need to get this so that it returns on its own. There's a big spring here. The spring's fine, it's just not moving because it's too tight. So we'll need to get that done. Repair this part down here. Lubricate the various moving parts. Platen turns quite freely. It's not particularly tight, but it does make some horrible noises, so that needs lubricating. The selector bars and encoder bars are frozen. None of them will move, even with the stop lever raised, they won't move. I suspect that's got something to do with this, so I'll need to take this off. This is kind of badly bent over to one side. I don't know if it's bent or not, or just pulled through. Looking on the back, there's kind of this plate on the back, the clamping plate, and it's pulled slightly through the slot. This guide plate is bent, so this bottom portion of this plate is bent, but it might just be because this is pulled halfway through. We may need to take this off, and hoping we don't, because it's a real pain getting this plate off, and then there's a lot of readjustment when you put it back on. So I'm hoping this can be straightened out with this still fitted to the machine. So and also this lever this operates on is stuck, it won't move, so although you can kind of get it to go down, it won't come back up again. So this whole thing is bound up. Okay, so I'm going to go through this. I won't do it on camera. I'm just going to go through and lubricate all the bearings and moving parts and see where that gets us. Before I do that, I'm just going to try unscrewing this and see if we can at least get this to free up. So just check the current settings so I can keep it where it is and see if we can get this to go back through where it's supposed to be. Yes, it was turned by 90 degrees. Okay, so no, unfortunately that is bent, so I'm going to need to do something about that. Essentially I think the pin on the carrier is bent. Okay, so it looks okay. So it is the plate itself that's bent, unfortunately. So I'm going to try and straighten this out with it still attached to the machine, but we may need to take this plate off. I'm going to start with that, and then we'll get back on camera, see if I can free this up. If not, we'll have to remove this plate and try and get it straightened out. Okay, well fortunately I was able to straighten this out with it still on the machine. What I did was to bend the inner portion of this plate, that's the inner portion of this half moon slot, and it was pushed in, so I've straightened it out. I've got it fairly flat all the way down, so if we slacken this thumb screw off, we can now move this smoothly over its entire range, so that's working fine. And we'll need adjustment later on, of course. And now the levers will move. They are very sluggish. If I try and pull one of these, you'll see it moves, but it doesn't return as it should. It's very slow, needs lubricating, and so now this is adjustable and it's not binding up anymore. I'll go through, lubricate everything else, and see how far that gets us. And to give some idea as to what we're aiming for, I've now lubricated this first lever, and when I release it, it was very slow to return before. You can see now it's instantly popping back to where it should be, so that's how it's supposed to work, not go slowly. This whole thing is very critical on timing, so if levers and latches don't move quickly in the way that they should, then it's just basically not going to work. Okay, so I'll do that for everything else, and hopefully that will cure a lot of the problems. Okay, it's about an hour later, and I've been through most of the machine, freed up various parts, lubricated the shafts, and it's now looking much better. The only bit that really gave me any trouble was this little lever down here. It's always the simple things that seem to take the longest. It's supposed to snap back like that, but whatever I did, it's only a simple pivot bearing, it just wouldn't return properly. So I took this off, and it was just congealed grease and dirt in there. So cleaned it out, re-oiled it, and that's now fine. This lever was also stuck, but that freed up fairly easily, and that's just the lever that controls the ratchet pull. So with that done, I then moved on, lubricated the carriage, the bearings. This was just really the guides. Well, basically all of it was just dirty and dry. So this now moves, and the ratchet works, and it's got about the right tension, and it's not too tight on the guide rails, and of course if we unlatch it, it now returns, which is what it's supposed to do. So that's the way it's supposed to operate, and the damper pot also now works. So that's that part done. I haven't addressed the encoder bars yet. They are now moving, but they're still too tight. I need to get in and lubricate the guides that they run on, but before I do that I need to be able to rotate the entire machine. It now rotates much more freely. It was very tight before, but now it rotates extremely easily. There's hardly any force required to turn it, which is how it should be. Now it's just, as I say, a combination of all the various bearing surfaces being too dry. So that now is up to the point where we can move on to starting to try and complete entire print cycles. I'll do it manually at first rather than just immediately fitting the motor, just to make sure we don't damage anything. But the next thing I want to do before I forget is to replace the rubber bumper on the print head. And I'm going to make the same modification to this machine that I did in the first series on the first ASR33 that I posted. So I'm going to remove this. I'm going to take this carrier out, remove the boss that this old rubber sits on. I'm going to replace it with a more modern type of bumper, and that will be a longer life and also easier to replace in the future. So I'll get this done. I won't do it on camera. I showed the previous one, but that's the next step. And then once that's done, I'll move on to the encoder bars, and we need to start getting these freed up so that we can try and operate the machine and run it through a print cycle. So I'm working my way through the machine, and pretty much everything is stuck. All the levers were sticking. Some are worse than others. It seems the grease has just completely congealed into a solid mass. So this lever here, there's quite a light spring, and this lever is kind of the print inhibit. This is what engages the main clutch, that sort of engages the main drive, or that prevents the main drive from engaging if it's not in the right place. It's on a light spring, and it should just pop back into the central position, but you can see it's not moving freely at all. Now I have tried to oil this, but it's just not freeing up. So unfortunately I'm going to have to take the main control shaft. There's a kind of a control shaft that runs at the bottom of this assembly, and it controls all the main levers that really control the different stages of a print cycle. So I'm going to pull the pin out that runs through these. I can't really do it on camera because as soon as I do that, all these levers are going to pop out. So all I'm going to do is push the pin out, take the levers out one at a time, clean the pivots, re-lubricate them, and we need these levers to move freely when they are released. So this, as I say, should just pop straight back into the ready position and it's not moving. So I'll get that done and see if that improves things. At the moment, by the way, when I try and do a print cycle, it's not really starting the print cycle at all. It's not going into its the mode where it's starting to scan the selection levers, so it's not starting the cycle, and that's because these levers are all sticking. Okay, well I think I've got it all back in the way it's supposed to be, and now as you can see the levers all move exactly as they're supposed to. They have to move quickly and positively back to where they're supposed to rest, otherwise the machine just won't work when it's running at speed. And it is important that all these are free. This probably explains why the plastic lever on the front of the machine was broken, because these were extremely stiff, and in fact this one wouldn't move at all at first. So as I say, I think they're all back in the right place. They're moving exactly as I would expect them to. And so what I should be able to do now is instigate a print cycle. So if I try and turn the main shaft, then this time when it goes round, the main clutch should be engaged as it gets to the point where this control pull is reached. So now it's hooking on to, this was kind of caught all the way back, it was in its pushed back position, and in that position it never causes the main clutch to be engaged, and so it doesn't start a print cycle. Whereas now, as you can see, or you possibly can see, it's hooked behind. There's a kind of a pull on the main clutch and it hooks behind there, and that's what causes the main clutch to be engaged or disengaged depending on what's going on. So when it's running, the motor's going all the time, and when it wants to print, the solenoid is energized and just causes this lever or this mechanism to engage the main clutch, and that does a print cycle. So just so much quicker than having to wait for the motor to spool up. So okay, what I'm going to do now is just cycle it around manually a few times, and then we'll have a look at the drive motor. Okay, so I'm getting to the point now where it's successfully going through print cycles. I don't know how well it will print yet. Some of the levers for the encoder bars are still a bit sticky, but it is starting to free up. Now the machine can accept data from two sources. One is from its own keyboard and the other one is from a remote machine. So the solenoid is used to start the print cycle if it's a remote machine that's triggering the print, or if you recall, there was an H-link bar that joined the printer to the keyboard, and that linkage is used to trigger a print cycle in a similar way to the solenoid. So although you can't see it, I'm going to press and hold the lever for the H-bar link. Now if I just start turning this with that lever down, then what will happen is it will get to this point, which is a normal resting position for the machine. Notice that the distributor is not rotating, so it's not trying to print anything. But if I let the H link bar up momentarily and then turn this, it will start a print cycle when the machine gets around to the correct point in the cycle, which, as you can see, the distributor has now started turning. I'm going to push the H link back down, but notice this carries on turning now because it started the cycle. It will now get to the end of the cycle and the distributor should stop turning to indicate that it's successfully completed the cycle, so we know that this control mechanism is working. Don't know what it's printing yet and whether all the encoder bars are working. We should get a similar action if we push down on the solenoid. This is how a remote machine would start a print cycle. So if I press this down, we should see this lever pop across, which it does, and if I now turn this, we should see it do a complete print cycle, and then the distributor should stop turning again. So you can see it started turning, so it's entered the print cycle. Notice that the solenoid's returned to its home position, and now, even though I carry on turning, the distributor has stopped. So that's how a remote machine would start a print cycle. It's the first bit, the start bit, is used to energize the solenoid, and then the following bits are the data that's being fed through to the mechanism. Or we can do the same thing again. I'll momentarily release the H bar, push it back down again once the cycle starts. Obviously this would happen fairly quickly normally because the motor is spinning at fairly high speed. I'll push the linkage back down again, and it will complete the cycle and then stop. So that's all working fine by the look of it. It's still a little bit tight, but nowhere near as bad as it was. And what I want to do now is have a look at the drive motor and see if that actually works. Okay, so we've got the drive motor. It does spin relatively freely. Doesn't look too bad. The windings a little bit dark, but they don't look burnt. I've lubricated the bearings on this just to make sure that if it does run, we're not going to do any damage. And what we're going to do now is just hook it up to the supply. So this motor it's got a split winding. It's got a run winding and a start winding, and this relay is used to start the motor up. So really it's a current controlled relay, and when the motor starts up, the current will be quite high because the motor will be effectively stalled, and that should pull the relay in and energize the start winding. That should cause the motor to accelerate, and then once it reaches a certain speed, the current should drop, the relay should de-energize, and it should just then run on the run winding. So it should be fairly low current. It should start up, run fairly smoothly, and then we should get a relatively low current shown on the auto transformer display. If we get a high current, anything over about half an amp, and we know we've got an issue, and we'll need to look at it in a bit more detail, but I'll get this hooked up. Okay, now I have done a leakage test on this. I know it's safe to touch when it's trying to run, but I haven't tried to run it yet, so I don't know quite what's going to happen. So I've got the auto transformer turned all the way down. We're getting 100 milliamps already. Okay, so we're getting an amp at 100 volts, so that's not right. Most likely this is the start relay. That's the same problem I had with the first of the ASRs that I showed. Hopefully it's not the motor. The motors are quite robust, they very rarely fail, but these relays are notorious for causing problems. So what we'll do is we'll open up the relay, have a look inside. It's usually fairly obvious when you look inside as to whether they are working correctly or not. So we'll just take the cover off this. So as I say, it's a current controlled, or should be a current controlled relay. What I found previously on these is this plate starts to straighten out or bend the wrong way. I can see no one's actually adjusted this. The marks that they put on when they adjust them initially are still undisturbed, but normally this gap would be quite small. What I'm going to do is try running it again, and we'll observe what the relay does and see if it's actually operating the way that it's supposed to. So be careful not to touch this, because obviously this is live, this is not an isolated transformer. So this time we'll keep an eye on the relay contacts, see what they do. Okay, well, it's odd, it seems to be closing when it starts up, and it does open, so unfortunately it's looking like it might be a faulty motor, but I'll look into this a bit more. And I don't think I've seen them when the motor connections have been reversed and the motor's trying to run on the start winding, but that doesn't appear to be the case here. It just seems to be drawing a lot of current, and it is possible the motor itself is faulty, but I'll look into it in a bit more detail and see if I can figure out what's going on. Okay, I've been messing with this for about 20 minutes. I attached a RMS reading current clamp so that I could get more accurate readings, and I was getting about 1.2 to 1.3 amps at 120 volts. Bear in mind it's a 120 volt motor, but the start relay seemed to be doing what it was supposed to, so it was looking like a faulty motor. What I did notice when I turned the motor off is it came to a very abrupt stop, so it looked like it was tight. I had tried spinning it by hand prior to trying to power it up, and it felt reasonably okay, a little bit tight, but when I tried spinning it after I'd run it, it was very tight. And if I now start this up, notice we're only getting about 30 milliamps when it's running. The start relay is doing its thing, and it's a lot of vibration, but there always is with these motors, but the current is now correct. And also when I turn this off, it cuts down very gently to a stop, and it feels much freer. What this turned out to be was the idler gear on the motor is on a separate carrier, and there are two bolts that hold that in place. And I don't know if it'd been hit or just it was maladjusted, but it was pushed too far in. It was pushing very hard onto the motor shaft, and because of the way these gears are cut, when the motor starts up, it pulls the armature one way, and that tended to make the whole thing much tighter. So that's, I think, what was causing the problem. It's now very free. I haven't lubricated it yet. I'll do that once it's fitted to the machine, but I am now getting sensible current draw when it's not driving anything. So what I'm going to do now is reassemble this, put it back into the machine, into the printer, and we'll try and power it up and see if it has the power to run the printer. Okay, I've got it all reassembled. I've got a fuse fitted, so if it does draw too much current it should just blow the fuse. I've got the auto transformer set to around 120 volts. Now it's not on rubber mounts here, of course, so it's going to make a horrendous racket if indeed it has the power to spin. Also, it's still a little bit tight, so I expect it to struggle a bit. These just need to be run for a few minutes once they've been stood for several decades, but hopefully it will start up. It won't do anything bad. I would say at this point, just in case it's part way through a print cycle when I start it up, or if there's something wrong and it goes into a print cycle, I don't want it damaging the print head. So I've already replaced the rubber bumper on the impactor for the print head, so I've replaced the old petrified one, put a new much more compliant one on there, so if it does go into a print cycle it's not going to do any harm. Okay, well we'll get it powered up. It will make quite a bit of noise if it rotates, but hopefully it won't just lock up. Okay, well that looks quite good. It's doing what I expected it to. The H bar is raised, so it's in continual print cycle mode. It's advancing the ribbon. You probably can't see it, but I can see the ribbon spool holder advancing, and that's what it should be doing at this point. It is operating the linkage for the punch as well. Okay, so that's it for this video. In the next one we'll try and put this printer through its paces a bit more. I still need to free up the encoder bars, but it does appear as if though it's going most of the way through a proper print cycle. Freed up the control mechanism, that's now doing what it's supposed to, The motor does have the power to spin up the machine, so previously it was locked up, of course, but luckily the motor does seem to be okay. I'll get the wiring put back in and the cable ties back in place, and then in the next video we'll see if we can get this to do a bit more.